So welcome to Module 6, parsing data and working with objects, and a few other things as well that really build on some of the scripting things we did in the previous modules. Now I actually want to start with storing credentials, because most of what we do will have some aspect of interacting with systems, and I need to authenticate to those systems before I can actually perform operations. So I have some identity that I need to use, and that identity will be proven to the system I'm trying to talk to, and then it will be authorized to perform certain types of action depending on the system. And so how do we get this credential? Now potentially there is something running my PowerShell script. Maybe I'm running it via a scheduler, and the scheduler lets me specify the account to run it as. Maybe there's a runbook engine that runs as a certain credential. Maybe I'm using a system like Azure Automation that lets me store credentials. But really, it boils down to many times I need a credential. Now, I can gain this in an online fashion by kind of asking for it. I can say, well, cred equals get credential, and I could also just do it in code. I could absolutely code in my script, hey look, user is password, administrator, password is password, convert the password to a secure string, and then create a credential by creating a PS credential object. Now, this is obviously terrible, because I've now got a credential just in my code. And this is one of the biggest problems that organizations face. Developers are writing something, they need a credential, and they hard code it into the script, into their code base. And there's a number of problems with this. There's a problem in that, well, if credentials have to be changed, I have to rebuild my code. There's bigger problems that, hey, look, well, the developer put the credential in the code, they kind of forgot about it. Then they upload that credential to some repository, and maybe it's public. I write this code, I put it on GitHub or Azure repos, whatever, and I've accidentally exposed a credential to the world. And it may not even be a credential. It could be a key to something private. So we need to be super careful about putting credentials or keys, anything sensitive, actually in our source code. That could be a C# file, that could be a PowerShell script. And so while this would absolutely work, I could run this piece of code. And so I've run that, and now I have a credential that I could use. But obviously the problem is that, hey, I've got this password just in the file as plain text. So that's really not a good thing. Now the next thing I could do is to store an encrypted version of the password. So I could create an encrypted version and then make a note of the output and then use that in the script. But it's still easy to reverse. It's just harder to quickly write that thing down. For example, over here, you can see, well, look, I've got a password of password123. And if I execute this line, and then we look at encrypted, well, there's this great big string. And what I could absolutely do in here is I could take this value, all of the value, not missing off the first character, and if I took that whole value and I put it in to there, and I ran that line, well, now I've got my secure password. And I could then use that. I can still reverse it, but if someone's just glancing at my code, they're not going to be able to quickly write down all of those characters. So it's a little bit better, but if someone's got my source code, they can easily still get my password. So still not a great solution. So we need something better. So the next thing we could think about doing is I could put it in a different file entirely. I could essentially create an XML file, or it could be JSON, it doesn't really matter. But XML is really good here because we can deserialize it back into an object. I can create my credential, my username and my password, and put it into the XML. And then in my script, I can import the XML back into a PS credential object. So that's remember the good thing about XML is we store sort of the data about the object, so it gets serialized into the XML, and I can deserialize it back. Then the XML can be kept completely separate from my source code. It's not in there. And I can then upload the source code. I just wouldn't upload that XML file. So that's better. I could put ACLs on that file. I could do further encryption on the file. But if someone gets that file, they can still get my credential. But it's better than having it directly in the script. But none of these are very good. This is the good answer. I can use Azure Key Vault. Now, there's kind of this love relationship between Azure and PowerShell. Azure makes PowerShell better, and PowerShell makes Azure better. They offer features to each other. Because any of those previous options we used, there was still a risk. I somehow leave a key in the code, I leave a password in the code, I have a separate file, but I upload that as well. They're just not good things to do. Azure Key Vault is a service in Azure. It uses hardware-based encryption devices that support various types of keys and secrets. And we like the idea of a secret here because, unlike a key, a secret I can store. It's ACLed, i.e. protected based on Azure AD credentials, and I can actually read the secret back. Whereas a key is saying I can put into Azure Key Vault, but I can't get it back out. I can use the key in Azure Key Vault to perform cryptographic operations, but I can't get the key back out of it. So now, instead of having that password in a file, I'm going to go and write it to Key Vault and then bring it back. Now, services like Azure Automation, services like Azure Functions, which have their own kind of credential capabilities, are leveraging Key Vault behind the scenes. But if I'm using Azure Automation, if I'm using Key Vault, then I can just leverage their credential, their secret storage capabilities, which is leveraging Key Vault on the back end. But now I can say, well, look, get the credential and save it. And I could create a little function to actually do that save. Now, what I've got over here in the sample file is using Key Vault. Now, you have to have a Key Vault first. So what you can do, if I go to my subscription, I have a Key Vault. And I have a number of secrets in my Key Vault. So I've got John's password, sample user. And what I can do here is if I go back to my code, I'm going to go and request a credential. So I'm doing this interactively because this is something that, hey, I'm going to go and populate the Key Vault. So if we just run this line, it's going to ask us for a credential. So I'm going to say, well, John, and I could do @Savile, whatever format I need for the username. So actually we'll do a complete name. And then a password, something super secure. Probably guess what I put in. And that's great. Now what I'm going to do is I'm going to store in the Key Vault. I'm going to call it sample password. And I'm going to use the secret value of the cred.password, which is a secure string. So if I run that, it's now gone ahead and written that into my Azure Key Vault. Now, I could stop there. The username, maybe I could just have in the code, or I might store the username in Key Vault as well. So here I have to store the username as a secure string as well. So I'm going to convert the username into a secure string, into a variable called secret user. So I run that. And I'm going to upload the username to a secret called sample user. So I'm going to run that as well. So now I've set both of those things. So if I now go and refresh, if I look at my sample user, I've got various different versions. I could select the current version. And if I do show secret value, it'll actually show it to me. Likewise, if I go and look at my sample password, I've got various different versions. So I can go back in time and look at different ones. And there's my password. So now I've populated Key Vault with my credential. So it's completely isolated from my script. I could upload my script quite happily. There's nothing in there. And now to use that credential, I would just grab the username. I would do the secret value text. So secret value text is actually going to convert it to plain text because I need the username. If I just run that part of the command, you notice there's my username. So I'm going to store that as username. Whereas the password, I'm just going to do secret value. I need to keep it as a secure string. So now if I just execute that, it will show me it's a secure string. So I'm going to save that as password. And just to prove it's valid, remember I can, in the Key Vault, I could look at the secret value text. That means just select UE. If I select the line, there's my password. I could also decrypt the secret string locally. So that's my $password. If I run this, I can see that's populated with password as well, just to double check it. And now to recreate my variable, I can just create a new credential using that username and password. Now, I can't use this credential because I put in a junk password. But if I actually had a valid password, and we can try and test it, and it's just going to fail because the username or password is incorrect. But you get the idea. If I actually populated that with a valid password, which unfortunately I don't trust anyone enough to just write it on the screen, but it would have worked. So now I can actually have my credentials completely separate and safe and secure, and just grab them from the Key Vault. Now you may say at this point, well, it's a chicken and egg situation. How do I authenticate myself to Key Vault to get the credential? And there's different answers to that. If I was running this in Azure, Azure has something called Managed Service Identity, an MSI. And this is just inherent to any kind of resource. It could be an app service plan, a web app, a function. It could be an IaaS VM. And within that VM, I can actually go and grab this MSI and use that to authenticate to Key Vault, proving I am this VM. And I would have given permission to this VM to be allowed to go and get that secret. So there's ways around having to have any credential stored in my code. I can actually use the fact that I'm running in Azure, for example, and this VM is allowed to go and get that. So that's how I can actually cure the chicken and egg, which is, well, how do I prove who I am without getting the secret first? So that's actually kind of a good way of achieving that. But use Key Vault, awesome service. And in the sample code, I've got writing and reading from the Key Vault. Now, I mentioned earlier about different authentication is I can actually use certificates as well. With certificates, I can actually just grab a user certificate for an account. I export the certificate out. The public key is imported into the target server computers into trusted people. I then map the cert to a user. And then when I connect, I just pass the thumbprint of the certificate. So I'm essentially just now using a certificate to do authentication. So I don't have to pass any kind of credential as well. Now, I don't know if this is used that much anymore with things like Key Vault. We tend to sort of use that more. But certainly I can use certificates if I want to. Then let's kind of switch tact. Let's look at working with some objects. So there's different types of variables. I can think about strings, a single character, a byte, an integer, a long, a decimal, a boolean, true or false, a date, time. We always start our variables with $. This tells PowerShell, hey, look, this is a variable. If it's $something, that means, hey, I am a variable. Now, often PowerShell is smart enough to just work out what something is. So I could just run one of these things and it's going to know what we are. So if we jump over, so let's put this in, variable types, and I'll run this little chunk of code. So if I run number is 42, boolean is true, string value is hello, char var is A. So if I look at the number get type, well, it's integer. That's what we want. If I look at the Boolean get type, well, it's a Boolean. That's what we want. If I get a string get type, it's a string. That's what we want. If we get a char get type, we get a string. That's not what we wanted. I just put in a single character, but I can have a single character string. So that didn't really do what we wanted. And so we can also cast. Casting is when I force something to be a certain type of variable. So in this case, if we jump over, and now we'll actually say, okay, well, didn't mean to do that. Let's hide that again. Control V. If I run that line, and then this time, if we do new char, get type, it's a character this time. So by casting it, by putting the type in the square brackets, it told it, hey, cast this variable to this specific variable type. Don't just take your best guess. I want it to be this. So get type lets us view the type of a variable. I can also test. I can ask, well, look, is this an integer? I can convert between types. Hey, well, number equals integer, number to string. For example, let's jump over here, and I can say, well, okay, look, is 42 int? If I run this line, it's true. I could say, well, $number equals int. We'll actually set it to 42. And then we can say $number to string. If I run that, it outputs the same thing. But if we actually went and did a get member, I can see what I now have. And I could also do a get type at this point. But I can see it's a string. So I converted, it's a function, a method of an integer is I can output a string. And there's a lot of different things I can kind of use for manipulation and conversions. So fun with strings. I can do checks. I can say, well, look, does a string contain another string? Now, there are various different operators I can use, and an obvious one might be contains. Contains does not do what you think it does. Contains is saying, well, look, does a collection of objects include an object? I think of it that I have an array of objects, and I'm asking with contains, does this array of objects contain this object? I don't want to do that. I'm trying to find out, look, does this string contain this substring? So what I want to use in this scenario is like. And we can kind of add strings together. We can check various things. So let's test this out. So we go over to here. So string 1 is the quick brown fox jumped over the lazy dog. If you've ever done a typing school, you've seen that. So does string 1 like fox? It's true. It contains fox. Likewise, I can add strings. So string 2 equals string 1 plus who was not amused. So if I output string 2, the quick brown fox jumped over the lazy dog who was not amused because someone was jumping over him. Don't like that at all. And this like is very powerful. I mean, there are other words I can use. There's, for example, a match. And match is super powerful. And match uses something called regex, regular expressions. So I can do a lot of stuff with match. but I have to kind of understand what that means and exactly how to use that the right way. But realize it is there. And so if like is not doing what I need, I can absolutely use match instead, and then I can use regex, i.e. those regular expressions, and there's a lot more things available to me. So about time. There's a whole bunch of things I can do with time. I'm actually just going to walk through these. So if we scroll down, so I can get today's date. Perfect. And I could say, well, let's get the day of the week. So today is Saturday. Got up at 3 this morning, went to the gym for 6 hours, and now I'm doing this recording. Typical fun Saturday for John. I can look at the details about that as well. I can say, okay, yep, it's 1:20 in the afternoon on Saturday. I could create kind of a date time and pass it a particular date. I'm telling it it's in format month, day, year, which is how it's done in America. In England, it's day, month, year, which is obviously very logical because we're going from very specific to more broad, day, then month, then year. But in America, they like to do month, then day, then year, for some reason we don't quite understand. So if I run that, I'm creating a date object based off of this. I can say, well, Christmas. Christmas is 25th of December 2019. So if I run that, I now have Christmas as a date object, and I can do things with that. I can say, well, Christmas minus today, and then show me how many days that is. So just Christmas minus today, if I just run that, it's giving me a whole set of information. But notice I've got a property days, hours, minutes, seconds, based on this. Well, I just care about the number of days. So if I output that, oh, it's 339 days till Christmas. That's a long time. I won't start being good for another 4 or 5 months. I can say, well, look, what was it 60 days ago? So I can do today, add days, minus 60. 60 days in the past. Oh, that was November 20th. I can create an object, $A, on a date time format info, and then spit out the days of the week. There's a lot of things I can do with date. And I like this particular minus 61. You'll see in some of the samples I have up in other kind of areas that I use this to find people that haven't changed their passwords for 60 days. So I'll compare the date of password change to that time. And if their last password change is older than this, I know they've not changed their password for 60 days, I can go and flag that. So they're super easy to create my own custom time objects and manipulate what I want them to be. Now, I've been kind of running all these interactively. I've not been running this as a script. I'm just using the script to have the lines and running them. So they're running in my kind of interactive window, so I can interact with those variables. But there is actually a scope for variables. By default, a variable has a local scope. It's only visible in its scope and any scopes created from it, child scopes. So if I was to run a script and that creates variables, those variables are visible within the script, they're visible within functions in the script, but they're not visible outside the script. But I can change that. There's local, global, available everywhere, script, available in the script only, private, can't be seen outside the current scope, not even children. And here's a little bit of code to kind of test that. And so what we're going to do is jump over, and we have this available to us. So I'm going to create this function called test scope. So I'm going to run this code. So by running it, it doesn't actually execute the function. It's executing the creation of that function. So now I have something called test scope. Remember, this is a terrible name. I should be using verb noun. So I could maybe call it test scope if this was actually a valid verb. And test actually is. So if I wanted to be good, I would actually say, oh, okay, we call this test scope instead. I'll try and set some kind of good example. So we change that to test scope. So I have to run this again. Now I'm calling it an actual proper function name instead of me being bad and setting a poor example. Okay, so now we have something called test scope. And what I'm going to do here is, so I'm going to define a variable, and I'm defining it just at my default, i.e. local. So if I run that line and then get the variable, I can see, yep, there's a default variable which has my default, i.e. local scope. I'm now going to create a variable with global scope. I'm going to create a variable with script scope, a variable with a private scope, i.e. not available even to children, and then I'm going to run the function. And what it's trying to output, remember, it's trying to output the default variable, which worked. It's trying to output the global variable, which worked. It's trying to output the variable defined at the script level, which worked. And then it's trying to write out the private variable, which didn't work, because this function is being called as a child essentially, and private means it's not available. I then went and changed the values. So if I go and look at my function variable that I defined within the function, i.e. a child scope, it is not there because this run, the variable was there, it closed because the functional calling is gone, so it gets lost. I defined a private called funcPrivate. That's not there either. Sorry, I actually just messed that up. I ran that in the wrong place. I should have run to prove it wouldn't be available here. But I did create a global called funcGlobal. And let's see if that's there. That is there. Because even though I'm in a child process at this point, child session, because I set it as a global, it's now available even after the function exits. So those are the different types of scope we can have for our variables. Now, what about when I use Invoke-Command? Because something very interesting happens using variables and Invoke-Command. And you might kind of guess what's happening, because when I'm using Invoke-Command, I'm running something remotely. So I'm creating a message to John. And I'm saying, well, look, write host the message. And that would seem to be okay. So if I tried that over here, message to John, and then run it against that remote machine, nothing. And the problem is, when I run Invoke-Command, it creates a new session. It doesn't have my variables. I have to pass the variables in. So I could, for example, create a script block content with a parameter, message to write, and then write out the message. So I would do Invoke-Command, run my script block, and I'm passing an argument list of message. Or I could just say, well, run a script block, write output args. I remember that default we get, and pass in as an argument list. So I have to specify an argument list to actually pass those things in. There's two different ways I can do that. So you can see here, well, I could define my script block content, sure. And this time I'll pass an argument list of message, and I get the message. Or I'm kind of lazy and I'll just use the default args, and that works as well. So good stuff. Okay, so there are ways that I can pass variables in to run remotely. I just have to pass it as an argument. Or I can use using. So PowerShell 3 introduced this, and obviously all of us are on at least PowerShell 3. Hopefully we're on 5 or ideally 6, because we're diving into our PowerShell core. And with this, I can just say $using : and then the variable that's defined at my local machine. So in this command here, I'm running pretty much exactly the same as the first line that failed, but I'm adding in $using. And this says, look, I'm going to use this from my existing machine, my existing session. So I run that. Oh, that works. So that's an alternate approach. I would rather pass it in as an argument. I would rather be very specific and actually say, look, I want to run this in that remote session. I'm passing in this data, but I do have that using option as well. So I previously mentioned hash tables, and they're used a lot in PowerShell because they let me store these name value pairs. And a hash table is just, I have the @ sign, then squiggly brackets. So I've got favorite things. And I'm just jump over to the code. So I'm creating favorite things is a hash table where Julie likes sushi, Ben likes trains, Abby likes princesses, and Kevin likes Minecraft. So if I run that, I can then look at the hash table, and there's the name and the values. Then I'm going to add in John and crab cakes. This was never true. It was never my favorite thing, but it lets me kind of tell a story. So now if I look at favorite things, well, yep, there's Kevin and John's been put in. John likes crab cakes. Well, I can change the values because although I kind of like them, they've never been my favorite. My wife and I went out for dinner a few years ago and to a nice restaurant. We both had the crab cakes. And then about 6 hours later, we were both violently sick for about 2 days. They poisoned us. So now I've been unable to even look at a crab cake since that time. So it's been a few years now. And so I'll put what really has always been my favorite food, which is steak. So I'm going to modify the hash table to set item John to be steak. So we look at favorite things again. Well, now it's a bit more realistic. John's favorite thing is steak. I can get values from there. So hey, show me what the favorite item is for Abby. Oh, it says princess. And I'll see hash tables a lot when I interact with certain types of object, certain types of creating a new object. I have to set a bunch of maybe parameters. I do that via a hash table. It enables me to very, very easily and without being very verbose, just say, hey, here's a whole list of properties I want to set and their values. So it's super powerful. But I can make it more powerful. One of the things I can do is create it and convert it into a PSObject. So PSObject lets me create my own custom object. There's also a system object, but custom properties tend to get lost with .NET functions, and that's kind of a bad day. I don't want to lose anything custom I add. So PSObject, I can add properties and a value for that new property. And I can add as many properties, as many values as I want. It's actually a super useful way if I want to return multiple pieces of data when only a single object can be returned. Imagine I created a function and I can only return one thing from a function, but maybe I want to return a whole bunch of things. Well, with a custom object, what I'll return is a custom object that can have a whole series of properties and values. So I could, for example, create a custom object, and I could add a member to that custom object. I'll create a note property with a name and a value. So I can create them that way. But a better way is to create it from a hash table. So if I jump over here, here's how I could manually create a custom object, that code I showed. So if I run that, great. If I look at my custom object, well, there it is. And because it's an object, I could also do format table. I could do format list. Not very exciting because there's only one property. Now remember, I have my favorite things. Well, I could take my favorite things. I'm not going to bother redefining that because I've already done it. I can create an object and I'll use my properties via the hash table I created. So I'm going to set the property to my hash table. So if I run that line, if I now look at it, there we go. I could format that as a table. It's an object. Technically speaking, it has a couple of methods. Not many because it's a custom object, but then it has properties. And I can see exactly what they are. Now in PowerShell 3, I can actually skip a step. I don't even have to manually define the hash table first. I can just say, hey, I'm casting it to be a PS custom object. I don't have to do new object. And I'm going to cast it to be a custom object. And here's the hash table. So I could just run that line in one go. And then $ForEach-Object2. There I am. So just different ways to kind of interact. But that's really powerful. You'll see me a lot of the times I'll take data and I'll put it into a custom object. Because then I can return the custom object, my comp info script. I put it into a custom object so I can manipulate it, send it down the pipeline. I can do a lot of different things with that. Whereas I can't do the same things if it was just like a hash table or a single property. So that's a really useful thing for us to kind of use. You've also seen me use this for each object. Now, we've already seen the $_. If I send down the pipeline, I can do a $_ and then various properties that send down the pipeline. But it's all within that pipeline. And even by doing a semicolon so I can have multiple lines, if I want to do a lot of computation, a lot of logic, it really doesn't work. Instead, I might have an array with all the different objects in and want to perform something on each of those different elements. Now, all I'm showing you here is there are different ways to use ForEach. I can be very, very verbose, use the proper output format. I could skip doing ForEach-Object and just write ForEach. I can skip even putting process. There's even an alias for the %sign that represents ForEach. So if you ever see something and then piping down the pipeline down to %, it's just doing a ForEach, i.e. run this on each object. And so in this example, it's kind of really simple. So this is creating an array. I've got the @ sign, and then again, what I normally call a bracket, but I've learned now is called a parentheses in America, even after 15 years. If I run this, if I look at $names, it's an array. Remember, I can access each individual item by doing a square bracket and a number. So 0 represents the first item, 1 the second, 2 the third, 3 the fourth, etc., etc. I can look, there were various methods. If I did $names get member, there are things I can do. So there's various methods available here. Let's look, for example, I can clone it, I can compare it. Let's look at the properties available. There's a whole, I can get the length, for example. There's also another one I'm having trouble finding right now. But there's different things I can do on this. So for example, if I just took my names, I could do length, and that's showing me the length of my array. There's 4, that's the length of the object, i.e. 4 items in the array. The other thing I can do, and I was trying to find it and I couldn't see it, is count. And I actually prefer to do that if it's an array. That actually shows me the count of the items. It's typically going to be the same, but I've seen some strange things. If it's empty, there's some weirdness that can occur. So I'll generally use count if I'm trying to see how many elements are actually in this array. Now from here, if I do ForEach-Object, hey look, write them out. Just write ForEach. Don't bother writing process. Just use %. Doing exactly the same thing. So it's kind of easy. Go through one at a time. For each does not equal for each. That makes obviously total sense. For each is an alias for each object if it's part of a pipeline. So if I have a pipeline, which is what I have here, when I write for each, it's just an alias for each object. However, if it's not part of a pipeline, then it's a PowerShell statement that behaves differently. It's going to load all the objects into a collection. So it's going to do that first. It's going to use more memory, but I may get better optimization of data loading and it's going to execute faster. For each object, when I do something, the data carries on down the pipeline. When I do for each, it does not. So to try and show that, so if I'm using ForEach-Object and to show things carry on down the pipeline, so I'm actually pipeline to ForEach-Object, I'm just going to set an input object from 1 to 100. And this is like crazy powerful. You may not have seen this, but this kind of 1.100, well, it just basically says, well, do 1 to 100. I can actually mess around with this. I could do 100.1. I can even do things like A to Z. Oh, my bad. Let's actually change that, sorry. A to Z. Let's try that. There we go. And I think this is kind of a popular thing. In America, if you get pulled over and they think you're drinking, say your alphabet backwards. What if I had a PowerShell window handy? Hey, I could quickly kind of get that to help me. Police were maybe a bit suspicious at that point, but you never know. But we just want to say 1 to 100. So we can use that notation. So what I'm basically doing is sending it 1 to 100 and outputting this. But rather than just outputting to screen, I'm sending it down the pipeline to measure object. So if I run this for each object, the count is 100 items. So this proves it carried on down the pipeline. Now if I use for each, now firstly I have to have a variable. So I'm going to say num is each 1 to 100. So num will be set to 1, 2, 3, 4, 5, etc. And then pipeline that num to measure object. And you're probably kind of suspicious already because I've got this squiggly red line. An empty pipe element is not allowed. So it's already kind of hinting that it's probably not going to work. Anytime you see a squiggly red line and you execute it, you're probably being overly optimistic. If I run that, yep, it failed. So that's kind of demonstrating about the way data goes down the pipeline. It just doesn't for the for each statement. Whereas for each object, it does. So that's kind of a pretty big difference there. Now, what about getting property values? Often you're going to see this $object and then the property. So I can do the dot to get to an attribute, get to a method. So I can see town.name, the past object.id. But sometimes it's not going to work as expected. And I just want to kind of walk through this example. Now I'm using getAdUser, and I don't actually have that available on this machine. So what we're going to do here is we're going to do an enter PS session computer. Now remember, the other thing I could have done here was implicit remoting. I could have imported the module into my local machine. But for right now, I'm not that worried. So I'm just going to say the SAM account name is John. And I want to look at the property called mail. So it's getting a number of different properties and including mail in there. So I can see, oh, that's my email. Great. Now I just want the mail. I want my email. So I'm going to say just select the object and I just want mail. Well, it worked, but Well, obviously it's giving me this property mail and then the value. So if in my script I was trying to do something just with the email address, it wouldn't be working. So I'm getting this name value returned to me. And if I actually go and do a get member on that, you can see, well, what I'm getting back is still kind of this AD user, this selected part, and I have this mail note property, and it's this name value pair still. But what I can do is I can do expand property. So now what I'm getting back, it's looking hopeful, is string. So if I try and look at expand property mail, I get my email address. So expand property is super useful for, as the name kind of suggests, expanding out properties. I don't want it as kind of that name value pair. So that completes this module. Coming up next is desired state configuration, that declarative type of deployment. Hope this was useful. As always, the materials are updated onto GitHub, and I'll see you in the next module. Thank you.